just wanted to go through our journey of managing artificial intelligence cost in our Fidelity environments. Our journey began just like everybody else's. There was a lot of projects running around. They came from everywhere. Nobody really knew what they were doing or what they were trying to do. And so the first thing we did is adopt the FinOps Foundation recommendation, which is institute business cases for all the projects. And that helped a lot because at least we could answer the general questions. How much money are we spending on them? What business value are we getting? And what are they going to accomplish, right? And so that was a good beginning, but it wasn't enough for us. We knew we were leaving a lot of money on the table in this space, so we wanted to go and do the next step. And so in a very Fidelity fashion, the next step was set up to be a lot of policy work and automation, right? Because those are our two favorite things to do to save money. And so what I did is I gathered all our information, our metrics, our cost measures, the utilization and everything, and I ran to Arun and Barghav, and this is what they did.
All right, so we have been doing FinOps for a while. So what's different with AML workloads? To start off with, compared to the normal traditional IT development lifecycle, the AML development lifecycles are quite different. They're inherently more iterative in nature, experimental in nature. If you give a model to a data scientist, they run dozens of training jobs till they get it right. And oftentimes the cost kind of compounds exponentially. And before you know it, what starts off as a small POC, what starts off as a small exploration ends up like a baseline cost, which kinds of often sometimes overshoots the actual business value, like Paul was saying. Along with that, all the AML workloads require some specific computes that might be GPUs, AI accelerators, which have a different cost factor compared to the CPUs. They're often multiple times the cost of CPUs, and this kind of throws our cost planning out of the box. And since the GPU utilization has been more recent, people are not used to effectively utilizing them. So we often find that the GPUs are underutilized, sometimes often left running, over-provisioned. So many inefficiencies in the compute space that we have seen, and the cost keeps adding up, and the compute costs just go just like the stock. Along with the compute, the key part of any AML workload is the data. And as you all know, the data keeps increasing year on year, and the appetite for data for the AML workloads is never ending, and it compounds so rapidly, and often the cost also along with it. And it's starting to rival the compute costs. At least the compute costs stay stable at a time, but the data keeps increasing and the cost of the data keeps compounding. So combined with the different experimental life cycles, the compute optimized, underutilized computes, the increasing data, there's also a slightly different challenge wherein when we are building a traditional app, we know what the development costs are, what the production costs are going to be. But here, we have very unpredictable training and inference costs. The training costs can be vastly different from your production costs, which makes it quite challenging. It kind of introduces a variability, and this variability makes our traditional cost planning not so effective. Oftentimes, we kind of differ. What we think is going to be the cost kind of ends up the diff is quite substantial sometimes. So to address this, we kind of thought, okay, how can we optimize the two main components of it? One is the compute, one is the storage. Let's start with the compute as it's the main driver for the ML cost at this point. When we talk about compute in FinOps, I think all of us start with the right sizing. I think when we are in cloud, I think that's something that we see day in, day out. We give permissions to people to spin up machines. They often spin up machines that are way bigger. Something that can be done on a 4 gig machine. People spin up 16 gigs, 32 gigs, just in case that maybe it makes their app run faster, just so that they can do it. That's our normal right sizing, and we have been seeing that over provisioning of resources happens quite a bit. In AML workloads, there are a couple of other things that get added to it. One is the GPUs. Like we said, GPUs are more recent, so not many people know how to utilize them effectively. GPUs can do lots of parallel processing. There are multiple cores to the GPU, but many people don't know how to utilize all the cores of a GPU, so they end up underutilizing it. And that's something that we have been trying to track, seeing how to measure the GPU utilization. I think you have heard in a couple of the keynotes over the last couple of days how people speaking about GPU utilizations, just not the cores, but the memory, the throughput, everything. So they get underutilized, and they kind of, with the varied GPU types, the workloads that get associated to the GPUs are also varying quite a bit. So along with the GPUs, also the jobs that you're running, the people pick GPUs very arbitrarily. Let's say you have a job which runs about 4 hours. You can pick a higher GPU which allows multiple parallel processing and bring down the run of the job to 30 minutes, but it requires a bigger GPU. So let's say you have a GPU which costs about $10 and the bigger GPU costs 100. So which one do you pick? You can factor in, okay, do I pick a bigger GPU and reduce my time for processing, or do I just pick a smaller GPU if my job allows it to run for longer times? So that's a lever that we have utilized to kind of find out our Goldilocks zone of how much time our job needs to run, so what GPUs that we want to pick. So to achieve all this, what we have started doing is implement a simple recommendation engine. When we started this out, we started with simple heuristics, depending on our expertise, our knowledge, our intuition, and our knowledge of the workloads that we deal with. We started with, okay, if this is an NLP use case, pick these types of machines, pick this size of machines. This is the data that we have seen. So we deal with like lots of data day in, day out. So if this is the type of data, pick these machines. So we started doing that, and it started giving good results. And over a period of time, we improved it with some data-driven sizing recommendations. But nowadays, every cloud provider also has their own recommendation engine. So it's a very good place to start. If you don't need to build your own recommendation engine, you can start with the cloud providers and iterate over that and see how it works out. But that's a very good place.
So to sort of summarize that, because it's a lot, right? There's new dimensions in here. It's not just about making your machines smaller. It's about using machines that are custom fit to the workloads you're trying to run, right? With the expected results on the end. So the heuristics are around what kind of workload is it, how big is the data set, and how do you apply that into what you're looking to do. And so it's new kinds of right sizing.
Exactly. But right sizing is only the first step on picking the right size of CPUs and GPUs. But the second is the actual machine choices. Do you actually need a GPU? When we talk about AML cost, I think it's like the elephant in the room. We all know that GPUs are expensive. Like you can see on the screen, an X-large GPU costs about $6,500 per year, and a similar CPU costs about $1,200. So that's a 5 to 6x factor that goes into it. So this cost differential is one of the key factors that throws off our planning, the budgeting, and everything that goes into it. So there are a couple of ways to tackle this. So one is more technical way, and the other is governance. Let's start with the technical aspect. And for the technical side of it, the field is evolving quite rapidly. Every day you see new techniques that the researchers are publishing. And one of the things that we have utilized quite a bit is something called quantization, wherein you can take a large language model and apply quantization to it to make it fit into a smaller GPU instead of a big. Instead of a 64 gig GPU, you can bring it down very much. You can apply quantization, maybe fit it into 8 gigs of GPU, and in some cases even it works well with a CPU without that much of a performance degradation. So you can pick and choose of how much you want to quantize the model and bring it down depending on what amount of performance degradation is allowed. So you pick your minimum. I think in today's keynote, they specified what is the minimum quality that you are looking at from your model. So as long as you're above that limit, you can pick and choose and play with that quantization and see how to pick and choose the machine.
All right, so as a FinOps professional, you're going to rely on the ML engineer to do all that.
Exactly.
You won't know how to do that, right?
You can just have the talk with your data scientists and engineers and say, hey, can you do something? Can you fit this instead of spinning up this big machine? Can we drop the performance a little bit? Can we use the new techniques to kind of figure out if we can do it on a smaller machine? And that would result in a huge cost savings over a period of time, especially when you're dealing with a large fleet of these machines. And the second thing is just dealing with the amount of machines that are there in the market. If you give, it's like an open buffet, right? There are every day there's so many machines that are getting added, so many types of machines, so many classes of machines. So if we leave it up to the data scientists and engineers, they're just going to be arbitrarily picking the machines without actually looking at which machine performs well, what's the price point for each one. They don't care. For them, every 32 GB machine is the same. They don't. They don't realize some are memory optimized, some are IO optimized, some are at a better cost. Maybe you have a reserved instance for some. So it's better to have a curated list of instance types that you maintain and govern, and have a continued conversation with your cloud providers to make sure that you are constantly adapting. The cloud providers release new machines every quarter. Every quarter, we see a new class of machines with a new price point, new performance points. The performance is constantly improving, so keeping up with that newer list is always helpful, and it will always give you a better return on the money that you're spending. So we spoke about right sizing, and we spoke about the machine choices. You did the right sizing well, you picked the right types of machines, but if they're not getting used, then it's like throwing money away. That brings us to our next point, resource management. If there's something that we want you to take away from this section, that is this particular slide on how do you manage your idle time? How are you making sure that your resources are actually getting used? You did your right sizing things, you managed to pick the right one, but if your machines are idle all the time, then it doesn't make any sense, right? One of the things that happened with us over the last few years is we moved all our development machines from on-prem laptops to cloud. So all our development now happens on cloud. Before, we used to build our models and everything on laptops and on-prem machines, but now we do everything on the cloud. As you know, most of the developers work at night. You work through the night, and whenever you feel sleepy, you just close your laptop and go to bed, or you leave it up and running. And laptops running all night doesn't cost anything. But if you do the same thing, you spin up a GPU development machine and you leave it running through the night, the costs get added up very quickly. That's something that we have observed in our initial days when we moved all our development machines. That's what we used to observe, that, hey, a lot of our machines are not getting used overnight, or people go for a coffee break, they come back, or they forget it, they look at so many things are happening. You get an email, you never go back. So we work with our data scientists, our cloud providers, on how to identify these idle machines, because we needed to identify it at a kernel level to make sure that there are no back-end jobs that are running on the machines. We needed to work with our cloud providers to figure out how to set up the scripts so that they run automatically on the back end to make sure to identify correctly that no processes are running, no notebook jobs are running, and we could shut down these machines after 2 hours. 2 hours is a bit aggressive, but this is a conversation that you can have with your data scientists and engineers, figure out the time that works better for you. It's flexible, but something that we want you to go back and ask and have this conversation with your people and say, hey, what can we do to make sure that we are utilizing our development machines to the maximum? The second point, in a normal ML lifecycle, what happens is the data scientists are constantly training their models, and after they train each version of the model, they deploy it as an endpoint and to test it out, the performance, whether it's giving the right responses, and so on. And oftentimes, they just leave it up and running. And some of the cloud providers that we have observed don't have the auto-scaling yet. It's a still evolving field that we normally have with normal APIs. So the endpoints used to just stay up and running. So we had to work with our data scientists to come up with a governance process to make sure that we are setting up the endpoints with a particular naming convention. We allowed them to only use certain naming conventions. And we used to bring down the test endpoints after 4 hours, irrespective of what's happening. So that if they wanted to, they could spin it up again, but these were just test endpoints. So anytime an endpoint gets spun up, we assume that, okay, after 4 to 6 hours, we bring it down, no matter what. And this has resulted in quite a bit of savings for us and helped us kind of rein in the cost. Last but not the least, this is something recently that we have been doing, is identify our non-24/7 resources and shut them down. So come Friday evening, we shut down all our non-prod, non-24/7 resources unless they are specifically tagged to stay up and running, and bring them back up on Monday morning. This is not specific to AML. You can utilize this anywhere, but this is something that we have found to help us multiply our savings quite a bit. Those 60 hours of idle time over the weekends helped us save lots of money. We bring down even some of the databases that we have, some test data that people just spin up over the week and do things like that. So when you go back after this conference, maybe first thing you'd do is sit down is look at your non-24/7 resources, make a list and see which you can bring them down over the weekend. You can just start like we did, manually doing it over the weekend and then automate it over a period of time. And you'd soon see that your costs are coming down quite a bit. So till now we have looked at all individual right sizing, machine choices, how are we managing individual resources. But more often than not, when we are in production, we do batch processing, ETL jobs, and everything is orchestrated. So let's look at how we pick the orchestration frameworks. When you go to an engineer and ask how you want to pick an orchestration framework, the cost never comes into mind. Trust me, I was an engineer and I never thought about orchestration costs ever. The first thing that I would pick as an engineer was the tech stack. If I know Python, I'll pick a tool which is supporting Python. If I know Java, I'll pick something closer to what I know as an engineer. So that's what we did when we first started out a few years back with our ETL pipeline. So we picked an orchestration framework that we were familiar with the tech stack, and we self-hosted it because we thought, okay, we have jobs that are running. But over a period of time, what we have observed is most of our jobs are running early in the day when the data is there, when we have some batch cycles, overnight batch cycles, like early in the day, 6 a.m., and only 1 or 2 jobs that are kind of spread over the 24 hours. But since we are self-hosting our orchestration framework, just to maintain the orchestrator, we had to maintain some instances, some databases related to orchestrator, and which added up a baseline cost through the 24/7. There are no jobs running, there are 1 or 2 jobs, but we were maintaining that compute for the orchestrator, the database for the orchestrator throughout the day. And then we kind of did a small POC on what would it take to revert to a serverless framework offered by one of our cloud providers. And we have soon found it was a slight technical challenge for us to move. There was a little bit of learning curve, but we did make that shift, and we have seen our cost drop by 95%. It was really good. And now we don't have the hassle of maintaining the compute, and it works for us because all our jobs are kind of staggered to one part of the day, and it's only sporadic jobs throughout the day. So it didn't make sense for us to keep our compute up and running.
So ironically, I gave a speech here 2 years ago on sustainability, and we go in detail about that example. So if you want to see more about that, go to YouTube and look up that video. It'll give you some good details.
Yes, I think Paul covered more details in that. So do go back and look at it, and please reach out to us if you have questions about that in detail. So apart from that, I'd like, in this section, we want to leave with one failure handling strategy. So recently we started looking at failures in cloud a little bit more differently than what we used to do before. So one of the key reasons for failure that happens in cloud is the resource not being available. You have a big ETL job that runs for 4 hours, and you have 10 steps in the job, and when you come to the final step, maybe you wanted to spin up an 8 gig GPU machine or 8 gig CPU machine, and the resource is not available because there are so many jobs running in your cloud account. You hit the quota. So what we used to do before is we used to retry for a couple of times to get that resource, and we just used to fail the job. And again, someone used to go back and re-trigger it. And since most of our batches are idempotent, we used to rerun the batch job again, and it used to work fine. But more recently, what we have been trying to do is, if we feel that, okay, this is almost the end of the job, there's only one more step or so, instead of failing the job, we just over-provision for that particular run. If an 8 gig machine is not available, we look at, okay, what's the next best-in-class machine? Maybe we spin up a 16 gig machine just to get that to successful. And that way we feel like, okay, we are achieving more successful jobs. We don't have that many more failures. We are able to handle. It's a little bit of on the cost, but we feel like it's a worthwhile trade-off to make sure that the jobs are successful. So right-sizing, picking the right types of machines, making sure your machines are not idle, and finally the orchestration. I think go back, even individually, if you start implementing it, you'll see the cost coming down quite a bit, and you'll see your compute utilization increase also quite a bit. So till now, we have been talking about the major aspect of our cost, the compute. But now I want to talk to the costs that are growing, that we have been seeing growing recently. Let's move on to storage. The key aspect of any AML project is data. The better data, you get better results. Worse data, you get worse results. It's as simple as that. So we take a lot of care in how we maintain our data, and that means it goes through a lot of pre-processing, a lot of post-processing. There's many versions of the data that people are working on, trying to fine-tune the features. So what ends up with all of this is there's so many versions of the data that keeps happening, and there's so many artifacts that keep getting generated. And this, what we have seen is this kind of exponentially grows our data. Our year on year, our data just keeps growing, and it's not a bad thing. It's actually good to have that much amount of data, but maintaining that large amounts of data manually has become a big hassle for us. So we have implemented some automated policies. The way that we approach our data is kind of, we divide it into 3 tiers: the hot, warm, and cold. Hot is the most recent data that we're actively using, the most recent features that we have curated, the most recent model artifacts that we have generated, and so on. So those we keep in the most recent available data, and that's what gets priced the most. And then after 60 days, we move all of those into an infrequently accessed tiers. Every cloud provider nowadays has automated lifecycle policies. You can leverage those, or kind of build your own version if you're doing it in an RDMS database or some object store of your own. And finally, depending on our data governance, on your data governance policies, on our data governance, we kind of, after 180 days, move it into cold tier or archival mode, where we move it into, and for governance policies, we keep it about a couple of years before we delete them. So having this tiered storage architecture helps in having a kind of handle on your data growth, making sure that it doesn't get out of hand. And once it gets out of hand, I think reining it back is a lot more harder than to just have these policies in place from the start. So apart from the data lifecycle policies, one of the other key factors is similar to the compute. How do we optimize on the storage? That's similar to compute. There's just so many storage options. There's on the high side, we have object, block, and file storage. And even within that, if you're looking at some SSDs, you have GP2, GP3, IOPS, different storage types for different purposes, some memory optimized, some IO optimized. So picking the right type of storage becomes a challenge in its own. I think sometimes it becomes like an art form. Like you are so iterating it over and over again. I think it comes by experience, some by best practices. So having the best practices and making sure that you're telling your engineers, your data scientist on how to pick these choices. Most of the AML workloads don't need low latency. Unless you are on the edge, you have an edge AML space, and you don't need low latency storage for most of your needs. You can go with object storage, which is the least costlier, and only in very rare cases go to the SSDs and EFS volumes. Similar to compute, how do you provision your storage also becomes key. Like compute, people often over-provision the storage when they're spinning up an SSD. Yeah, they'll think, okay, I have a lot of data to deal with. Maybe I need 1 TB of SSD. And they don't end up using even 10% of it. So maybe don't give them access to, it becomes a matter of access management, wherein just maybe give them access to spin up 5 gigs, then only on exception basis increase the storage on use case basis. Along with these two, we want to kind of talk about 2 other aspects that we have found very useful. In AML workloads, most of the data scientists and engineers are comfortable dealing with CSV data. So most of the data that you would be seeing is in CSV format, because that's what any data engineer or any data scientist is more familiar with, because the tools allow that. But in recent times, we have been leveraging columnar formats because it allows a lot more compression, at least for the cold archival data and cold storage data. We kind of move them into columnar formats and compress them, which kind of helped us manage the data cost a little better. Finally, deduplication. I think this is one of the most key aspects. It is not technical, but just having a data catalog in place to make sure that you have visibility in what kind of data that you have, and having a conversation with your data scientists and engineers to make sure that they're reusing the existing data rather than everyone doing the same thing again and again, kind of duplicating the same data sets across the space goes a long way. And trust us, we have done this, and this has helped us so much more. And in turn, it helped the data scientists and engineers by saving their time too, just having a pure data catalog, having the conversations, having governance process in place to make sure that people are not redoing their. I know everyone wants to kind of redo their data because they don't trust their existing data. But just having this one, I think, in place, having a proper governance goes a long way. So we have spoken about data lifecycle, I think storage. Now we want to talk about something that gets ignored the most, and I think most of the data scientists and data engineers kind of, I don't think, even know about this. That is our data transfer cost. If you're in a multi-cloud system, I don't think if you go and ask data engineers or data scientists, out of 100, I don't think 90% know that there's a cost associated with transferring data from one cloud to the other. People just assume, hey, I'm just transferring costs from my on-prem to here or from my AWS to on-prem, other places, but there are actually costs. So creating that awareness and having a egress transfer costs in place is really helpful. So what we have done is we kind of now do batch transfers. I think even in today's one of the keynote or yesterday's, someone was talking about how they kind of went away from streaming to batch to kind of reduce the egress data transfer cost. That's what we have been doing too. We kind of batch them, and like we said, we use columnar formats to compress the data, make sure that we are not transferring huge amounts of data in and out of the cloud unnecessarily. And we try to use the latest version, right? Like bring compute to the data rather than data to the compute. Wherever possible, we try to process the data where it is rather than moving it around unnecessarily. So we have spoken about compute, storage. I think as doing all of this kind of helped us save a bunch of costs. But if you're doing all of this but have no visibility into your systems, I think that comes up with its own risk. So we just want to reiterate about observability a bit.
All right, so wow, that was a lot, right? He covers a lot of data really fast. It's a little lighter from here on out. So that's I'm talking. There's a few things. So, as a FinOps professional, observability is, one of your most valuable tools. And in the AI ML space, the GPUs that everybody talks about, you may need to do work to actually get visibility into it. Native tools probably will work. Vendor tools might need some help. Internal tools probably need some agents added. You need to do a little bit to get that visibility going. In addition to that, these services are big, right? They have a lot of things rolled into them. So to find your cost drivers, you need to really dig deep into your data. We had to go all the way down to like the item level to find our major cost drivers in here. But once we did, we figured out very quickly how to take care of them. That's where we identified the automation that Barghav built around shutting down on the weekends, turning your GPUs off, turning off your sessions, your endpoints. All of that rolls together very easily once you can find it. The other thing I want to talk about is a little bit not related to costs. We also took a very central approach to our AI by having one team do all the work in this space. And it's very valuable because these data engineers have a lot of access, and we're trying to keep control of it, keep the footprint very small in their space. And a lot of things we do around there are policy driven. And so you have a smaller group of people that have the policy enforcement and knowledge that you need to keep that in there. They also have become very good partners around cost collaboration. I mean, you see the work that's been going on here. If you have to go chase a lot of people to do a lot of different AI transformations to make your cost effective, it's really hard. The other thing is, we get a very core group of people that are very technical. So they can keep up with all the changes, the model changes, everything that's going on here. The pace of change here is way faster than anybody that's not dedicated into it can keep, right? And the other thing is we were able to actually improve our budget frameworks to get back within our standard tolerance for all our cloud spend in here, which is a pretty big accomplishment. All right, now what all you're waiting for, what does this look like in action? So the 3 automations that we talked about, shutting all those things down, saved us more than 35% of our total spend. That enabled us to do 4 more projects in here. So we provided significantly more business value. And you all see the trend line in there. That's what we all love to see as FinOps professionals. But the data geeks in here, if you look at the dots, which are daily spends, we see something interesting where the variation increases greatly as we drive that down. Normally variation's bad, but here it's really good because it shows you we've eliminated a lot of the waste and we're close to the actual capacity needs for every individual model. So at that point, thank you for coming today. We're gonna open it up for questions for all of you. And somebody's coming around with a mic.
First, you get a round of applause.
Oh.
And maybe another later too. What are your questions, folks? Over here.
Yeah, you mentioned the automatic shutdowns, apparently stuff that you built. I'm curious to know more about the tooling around that. Is it more of a centralized tool, a platform where people provision through, are using infrastructure as code? Like, what are the controls there which make that happen so that you can have the automatic shutdowns on weekends?
So I'm gonna give you a generic answer, right?
Sure.
So what we did is, a lot of these projects have lifecycle rules built into them. So if you're trying to implement them yourselves, you can go out to like GitHub and some of the repositories. They'll have lifecycle rules that you can engage into to do some of that work. It'll get your engineers kicked off in that process. We can't tell you exactly how it's done because everybody's gonna be a bit different.
What cloud do you use, like, primarily? What's your?
We're in 2 clouds, AWS and Azure.
My question won't be valid. No.
What?
What? Like, again, in the past, just curious. What do you do to shut the systems down? Do you do it manually? Do you write an ML for it? Like, what does that look like across the 2 platforms or across the 2 CSPs?
So like I sort of said, we've actually only done this in 1 currently, just because of the designs of where we're running certain things. But it's all based around lifecycle rules and custom-built automation.
Hi, that was a great talk. Can you talk a little bit about what phase you're in? Like, how much of this is training workload that you optimized versus inference?
That one's for you.
I would say about 60% is training. Because most of the test endpoints that go into it, all the development machines, most of it is training part. So 60-65% it would be training, and the 35 would be the inference side of things, where we bring down the weekend machines, the production, the non-prods, the integration test machines, and everything. So it would be a 65-35 kind of split.
Hi, great talk.
Thank you.
How do you guys curate the list of instances? Because we run into a similar issue where we have an interface and big long list of servers that data scientists face, and I don't know if they have any rhyme or reason on how they pick it. Besides, the bigger the better. But,
Why don't you grab us after? We can talk. That way
Excellent.
You can interact and get a more detailed answer.
Oh, thank you so much.
Yeah.
We'll do.
How do you handle exceptions for like off-hours things or one-off instances where you have to spin back up the instances?
Sorry, I didn't get
Do you have an exception process for the automation?
Oh, we do. We handle it through tagging. So, but once it tags, it comes to us saying, hey, someone asked for it. So we go and check on why they would need it. But once it's there, but we do it through tagging. There's a specific tag where you can add that particular tag and it wouldn't get deleted.
Is that a manual process to turn it back on, or is that something you have to automate?
No, it's automated. But we kind of recognize like who added the tags. So we go and ask like, hey, why did you? Is there any particular reason? So we have some governance in place that happens after the fact, but people can opt out of it if they're doing something over the weekend, they're running some performance checks or things like that. So we do have an opt-out process.
Okay, so my question is from a colleague. How have teams tackled the challenge of labeling and tagging consistency across environments, particularly in Google Cloud, where certain managed resources limit control?
So
We
I'm
don't-
going to start with that. We don't use all the clouds.
Mhm.
You know, for us, we have specific mandatory tags that are just required on every single resource. And what was the other part of the question?
So this is, we're struggling to enforce, and automate consistent tagging.
Yeah.
So we're having a little bit of a struggle with that, and we wanted to see how you guys are.
Yeah, so we do a couple of different ways in each of our clouds. You know, some of it's deployment enforcement, some of it's policy enforcement. So it'll vary by cloud how you go about doing that. And I don't have any Google Cloud experience, sorry.
That's okay. Thank you.
Go for another one.
Sure.
You mentioned a data catalog, and I love that idea. You know, people being able to find data that already exists. They don't need to recreate it. What I find difficult is getting all the data registered and having teams register that data. So can you tell me a little bit about how you handle that, and if that's like a central tool, again, where people go to look at the data catalog?
We use a specific tool. I don't know if I can call that out. So
Okay.
maybe after the talk,
Sounds
I'll
good.
give you a little bit more details.
So you said like you tag your resource. I want to know how big percentage your resource get tagged, like how you treat those untagged resource.
So it's a extremely high percentage. I would say it's north of 80%. You know, a lot of it that's untagged is untaggable in our space.
Yeah, we also get like above 80% tag resource, but still like always get lots of untagged.
Well,
So-
some of the services aren't taggable still, right? So
Yeah.
you could only get so high.
Yeah, because original we create like a mandatory tag policy. Then I found it's impossible. They still always has some resource untagged. So just want to know at any
Yeah.
place they can make 100% happen.
Yeah, and there's a few services you can only tag after deployment too. So, you know, there can be some complexity in there. So you should like look service by service and see where your gaps are.
Paul, what's your AI strategy?
Our AI strategy is very simple. In the immortal words of Jen Hayes, to get the most business value out of every dollar spent.
Yes.
Not
In the
business.
cloud.
How do you structure your budgeting cycle? Are they static annual budgets, quarterly reforecast, or fully rolling forecast? And what cadence has provided the best agility without creating churn? And just to give some context to that, we're curious about how often others update forecasts and what triggers a reevaluation, such as like spend anomalies, org changes, and product language.
All right, so generally we do a bottom-up, top-down budget once a year in a planning cycle. And then we do regular reforecasts through some automation and just trend analysis on a monthly basis. And so we have a very mature process in there. Generally, our variances are very low in there too, because we've been doing it for quite some time.
Hello. I think, hopefully I understood this right, but I think earlier at one point you talked about looking at the managed services for AI models. I guess that's kind of Azure OpenAI, Bedrock, things like that. Did you put pricing models together to look at, okay, this AI use case, if we did it in managed service versus IaaS, or how did you approach that?
Yeah, so in our business case process, you really do that sort of analysis about, you know, this is my design, what is it going to be? And then you can do optionality as part of that. So it's done upfront in the estimation process. Usually we do like a POC first too, so if that's successful, you still get another chance to redesign it if you need to, if you're looking for something that'll improve it.
And was that based on the LLM that was planned to be used for that particular?
That'll be by project, so I can't.
By project.
Yeah.
Thank you.
And I get the last question. Since you figured out how to use ML, what color is the fox going to be next year?
It's going to be blue because it's been orange and green. So now it'll be blue.
It'll be blue, folks. And with that, say thank you to Barghav and Paul.
Thank you so much.
Thank you all.
Hey everyone, producer Andrew here. Thank you so much for watching and for your support. For more FinOps X 2025 content, go check out our YouTube channel. Like, subscribe, and leave comments and questions for all of our wonderful speakers. We appreciate your support.